Okay, let's go ahead and take a look at our next lesson, which is lesson 7. And today we are going to be learning a new skill. So we've kind of been doing the same thing, right? We've been um, we've been taking area models and decomposing them to show equivalent fractions. Well, today we're going to add on to that knowledge that we already have, and we're going to use area models in multiplication to show equivalence of two fractions. So by the end of today's lesson, you should kind of master the multiplication part of this. Remember, yesterday during our sprint, we had a lot of multiplication tied into the sprint. So, and we have been writing multiplication sentences, but we're just going to kind of take it next level with this lesson. So let's go ahead and get started. Now, hopefully you have a whiteboard or a scratch piece of paper because remember yesterday I told you, and I've kind of been reminding you of this, but every time that I'm teaching, you should be listening and doing, right? Because you're going to learn best from that. And I want you practicing these skills. So the first thing we're going to do is draw an area model and record 1/3 on the area model. So let's go ahead and flip over to Miss Johnson's Jamboard here. And I'm going to draw an area model, and you should be doing this at home. You can pause if you need to. And we're going to show 1/3 on the area model. So you should be thinking about how many total pieces that means it should have and how many should be shaded in. So for 1/3, you should have 3 total pieces, right? And 1 piece shaded in. So here is 1/3. Okay, awesome. Let's see what our next instruction is. It says draw a horizontal line across the area model. So remember, horizontal lines go left or right, and vertical lines go up and down. We've been dividing our area models using both, but mostly vertical, right? So now I want you to take one horizontal line and just split up your area model. So I'm going to take it, and I'm going to use a different color. You could maybe just do a dotted line. But there we go. Now we have our horizontal line, and it's divided it in half. What happened to the size of the fractional units? So I want you to tell me what happened to the size of the fractional units. Well, hopefully you said, Miss Johnson, it cut it in half, right? So we literally took the line, split it down the middle, and it cut it in half. So now instead of having thirds, we have 1, 2, 3, 4, 5, sixths, right? We have sixths. And how many sixths do we have? Well, we have 2 sixths, okay? So hopefully you can take a look now at this multiplication sentence here, and you can see what happens, that they're equivalent fractions. So let's go back. First of all, let's write a multiplication sentence. So I'm going to switch back to my black ink, and hopefully you're saying, well, I know that in order to get from 1 to 2, I would have to do 1 times 2, right? So that would give me the top portion. Now, I also know on the bottom, whatever I do on the top for multiplication, I need to do to the bottom. So it's a little bit different than adding fractions. When we add fractions, remember, we only add the numerator. When we multiply fractions, we actually multiply the numerator and the denominator. And whatever we multiply the numerator by, we want to multiply the denominator by. So if I multiply the top by 2 to get to 2, I multiply the bottom or the denominator by 2, and we know that 2 times 3 is 6. So now you can see, not only from looking at your tape diagram, that 1/3 is equivalent to 2 sixths, but you can do the multiplication to show how you get 1/3 to be equivalent to 2 sixths, right? We are just multiplying the fraction by 2. Okay, so you can see they've done the same thing here on the slides, and we call these equivalent fractions. Now, I want to go back. I want this to go away. why didn't doubling the number, okay, the question is, why didn't doubling the number make the fraction larger? So why didn't it make the fraction larger? And you're saying, well, actually the fraction is larger, but it's really not, right? Because we're saying they're equivalent. It's actually, what it's doing is breaking your fraction into smaller pieces. So remember, I've been saying 1/3, you actually have larger pieces, right? When you double it, you're cutting them, the pieces are becoming smaller, right? So we're taking the same fraction and we're just making the pieces smaller. All right, so let's look at another one. This time they want us to take an area model and represent a whole with a vertical line, partitioning it into 2 halves. So they want us to make, and then they want us to shade 1/2. So basically, in other words, what they're wanting us to do is just show 1/2 with an area model. So go ahead and pause here. Take a minute to draw 1/2. And hopefully your 1/2 looks like this, right? Just 2 pieces. 2 is the denominator. I have 1 shaded in. So that is 1/2. Okay? If you wanted to rewrite 1/2 using 4 times as many units, what would we need to do? What would we need to do? So let's do the multiplication first. 4 times as many units. Remember, I would multiply by 4, and if I'm doing it on the top, then I'm also doing it on the bottom, right? 4 times as many. 1 times 4 is 4, and 2 times 4 is 8. So if I want 4 times as many units, that means that 1/2 would become 4/8. So we know that 1/2 and 4/8 are equivalent. Now, how can I show that on my tape diagram? Well, I would have to make 4/8, right? So now I want to divide it into 8 total pieces. And 4 should be shaded in because 4 is my numerator. So now I could show using multiplication and decomposition of my area model that 1/2 is indeed equivalent or equal to 4/8. So take a moment, just kind of look at this, pause here, and I want you to just kind of look at this tape diagram. So go ahead and pause the Nearpod. And then we'll come back together. So hopefully you were able to see that the size of our original fraction, it didn't change, right? The pieces just got smaller. Okay, so now what I want you guys to do is I want you to make an equivalent fraction to 1/4. So let's go ahead, and the first thing we need to do is just show 1/4, right? So what would 1/4 look like? Pen doesn't want to seem to work here. I want you to draw 1/4 for me. So when we have 1/4, we have 4 total pieces, and only 1 is shaded in, right? So this is 1/4. Now what can I do to show another equivalent fraction? What could I do to this tape diagram? Well, you could do a couple different things, right? I'm going to take it and I'm just going to draw one horizontal line down the middle here. And now I have what? I have 1, 2, 3, 4, 5, 6, 7, 8 as my denominator and 2 shaded in. So I know 1/4 should equal 2/8. Could I show that using multiplication? Well, 1 times what equals 2? 1 times 2. I have to do the same thing to the bottom. So I have to take 4 and multiply by 2. And 4 times 2 is, in fact, 8. Okay, so hopefully you're starting to see how multiplication works. It doesn't change the fraction, right? 1/4 and 2/8 are the same size. It just changes the sizes of the actual pieces. So let's take a look. And they did it the same exact way, okay? So they did it the same exact way. They did 1/4 and 2/8. You might have split it with 2 horizontal lines, and that would work too. Let's look at that. So let's take it and do the same thing. Let's look at 1/4. Okay, so here's 1/4. And this time, instead of 1 horizontal line, let's see what would have happened if you drew 2. So let's draw 2 horizontal lines. Okay. So when you draw 2 horizontal lines, that means you're saying 1 times 3, right? Because now I have 3 different groups. 1, 2, 3. I have 3 rows. And I have to do the same thing to the bottom, right? So I have to do 4 times 3. Well, what is 1 times 3? 1 times 3 is 3. And what is 4 times 3? Well, 4 times 3 is 12. Okay, do I have 3 twelfths up here? Well, let's count. I have 3, 6, 9, 12 total pieces. And look, I have 3 that are shaded in. So yes, it is 3 twelfths. 1/4 and 3 twelfths are equivalent or equal. Very good. Okay, the next thing we're going to do is, instead of starting with an area model, we are going to show an equivalent fraction without doing the area model first. So that means we're going to have to do the multiplication piece first. Okay, so we're not even going to draw 1/3, but we are going to come over to our Jamboard and we're going to write the fraction 1/3. And we're going to come up with an equivalent fraction for it, okay? So let's go ahead and just draw 1/3. And now, without doing an area model, let's come up with a different fraction. We've already multiplied it by 2, and we've already multiplied it by 3. So let's just go ahead and multiply by 4 and see what happens. So if I do the top by 4, I also have to multiply my denominator. So I did my numerator 1 times 4, and now I have to do the bottom, or the denominator, which is 3 times 4. And now I get 4 twelfths. So let's test it and see if that's right using our area model. I start with 1/3. 3 total pieces. 1 is shaded in. I'm going to cut it 4 times, right? So I'm going to make 4 rows. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's my denominator. I've got 4 shaded in. That's my numerator. So 1/3 is equivalent to 4 twelfths. Let's do, maybe we did fourths. Is that what we did? No, we did 1/4. Okay. So the lesson, they're showing us thirds. They're showing how if you take 1/3 and they multiply by 3, they're showing us times 3. So they're doing the numerator times 3. They're doing 1 times 3 equals 3. And they're also doing the denominator by 3. 3 times 3 equals 9. So they're showing that 1/3 could equal 3/9. And look, then their area model proves it. So now they're doing the multiplication first and using the area model to prove it. Okay, so here's 3, 6, 9 for your denominator. and 3 shaded in for your numerator. So the area model proves the equation 1/3 is equal to 3/9, just like our area model was able to prove that 1/3 was equal to 4/12. Okay, so hopefully this is starting to really click with you. Now, that's pretty much it for today's lesson. You will get some practice today by doing the problem set. So when you access the lesson 7 problem set, number 1 is going to have you start with the shaded unit fraction. It's going to be decomposed into smaller units, and then it wants you to express it in a number sentence using multiplication. And it's the first one's been done for you. Okay, so you can see it started off as 1/2. They had 2 pieces drawn. 1 was shaded in. They decomposed it into smaller units by drawing the horizontal line. And now they have 2 rows, so they had to multiply the numerator by 2 and the denominator by 2 to prove that 1/2, in fact, is equivalent to 2/4, okay? For B, they've already decomposed it for you. Now you just have to write the multiplication sentence. Let's go ahead and look at C. I'm guessing the next ones they want you to do probably have not been decomposed, but let's pull up the work and take a look, okay? So if we go into the problem set for Friday, give me just a second. Oh, C and D have also already been decomposed for you, so you just need to write the multiplication sentence. Now, number 2 is where you need to decompose. So you're going to decompose the shaded fraction into smaller units using area models and express using a multiplication sentence. So this is where you're going to draw your own lines and do your own decomposition. E wants to know what happened to the size of the fractional units when you decomposed. What happened to the total number of units in the whole when you decomposed? Number 3 wants you to draw 3 different area models to represent 1/3 by shading and decompose them into 6, 9ths, and 12ths. So for A, you're going to take 1/3 and make it 6ths. For B, you're going to take 1/3 and make it 9ths. And for C, you're going to take 1/3 and make it 12ths. And then it wants you to use a multiplication sentence to show how they are equivalent. So how is 1/3 equivalent to 6ths? For B, how is 1/3 equivalent to 9ths? For C, how is 1/3 equivalent to 12ths? Okay. I really like this problem set. I think this is going to give you guys some really great practice. Since we did move on today, it's going to be really important that you get that done. And then we'll follow up with the exit ticket. Okay, so good luck. And if you have any questions, feel free to reach out.